Hello coders, welcome to the channel. I hope you're doing well. Today we'll be solving LeetCode daily question 1513. Let's jump right into it. Given a binary string S, return the number of substrings with all character ones. Since the answer may be too large, return it modulo 10 to the power of 9 plus 7. So the question basically says, given a binary string S, meaning the string has only zeros and ones, return the number of substrings with all character ones. So we basically have to return the count of number of substrings which contains complete one. So the flow of this video would be first we'll be solving the brute force approach and then we'll be moving to the optimized approach. The brute force approach would be that we will be computing all the substrings in the string that are possible, and for every substring we will be counting the number of ones. If the substring contains complete ones, which means that is the desired substring that we are looking for. If not, we will not be incrementing the count. If it is, we'll be incrementing the count. So let's do the brute force approach. Here we are computing the substring which starts with from ith index and ends with jth index. To make it a bit more optimized, let's count ones as we traverse the substring instead of counting it from I to j and making it n cube complexity. If s of j 1, we will increment the 1. So what we'll be doing is, if count ones is equals to j minus I plus 1 is basically a substring length which starts with I and ends with j. If the number of ones present in the substring is equal to substring length, that is what we are looking for, that is the desired substring that we want, and we will be incrementing the count. One thing, we didn't initialize the count and we didn't initialize the mod as well. As we can see the time constraints, the string length is 10 to the power of 5, so since we are doing n square complexity, it should give us time limit exceeded. Let's see. Basic test cases are passed. And yeah, as we expected, we have got the time limit exceeded. Now, we should be diving into the optimized approach. Before getting straight into the solution, let's examine the substring that is provided. Let's basically look at the number of substrings that are formed in this string with all ones by dry running this. Now, if we look at the substring with all ones, number of substrings that are formed with all ones are basically from these two substrings. So one substring which starts with index 1 and ends with index 2, another substring which starts with index 4 and ends with index 6. The number of substrings that are formed here would be substring which starts with 1 and ends with 1, substrings which starts with 1 and ends with 2, substrings which starts with 2 and ends with 2. Here if we see, so index 1 is making 2 substrings with all ones in it, and index 2 is making one substring with all ones in it. Now if we look at the 4 is one substring with all ones in it. 4 to 5 is a substring with all ones in it. 4 to 6 is a substring with all ones in it. 5 to 5 is a substring with all ones in it. Similarly 5 to 6 and 6 to 6. If you see 4 is making 3 substrings, 5 is making 2 substrings, and 6 is making 1 substring. If we look at this combinations, we can basically see a pattern here. That is basically, if a continuous one substring is of length n, then number of substrings inside of it that can be formed which satisfies our condition will be 1 plus 2 plus 3 plus up to so on n. If we see here 1, 2, 3 and the substring length is 3. Here the substring length is 1 plus 2. Okay. So the number of substrings that can be formed from that substring is 1 plus 2. Our question now drill down to first getting the size continuous ones in a string and going n into n plus 1 by 2 for that portion to repeat this throughout the string. Let's comment this out. So count once. Let's code the approach that we finalized. Here, if as we are going to increment the one. Count once indicates the continuous length of a substring with all ones in it. The moment we have encountered a 0, meaning the continuous substring of 1 have ended. So now what we need to do is basically we need to do n into n plus 1 by 2. N plus 1 by 2. We need to increment the answer and then we need to make this 0 because we have encountered a 0 and we need to return the answer. Let's run this and see if the base test cases are passed with the approach that we have seen. No, I think it will not, because a small bug here is that when we encounter 0, then we are computing the sum of the ones that are prior to it. But if we encounter the end of the string, then we are basically ignoring the last set of points that are present. So we need to basically paste this here, and now I think it will work. Let's submit this and see if we encounter any failure. No, and we can see 100%. Thank you so much guys for watching. Please like, share and subscribe for more such content. Please comment